Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of vectors in R2. So as per the problem, parallelogram OPQR is such that vector OP equals negative 724 and vector OR is equal to negative 8, negative 1. In part A, we have to determine the angle between the vectors OR and OP. Now in this parallelogram, OPQR, point O represents the origin, and we are given the position vectors for point P and R. So point P is negative 724 and point R is negative 8, negative 1. So the first step is to sketch these points. So O is the origin, the point R is negative 8, negative 1. So somewhere here, and point P is negative 724, so that will be somewhere here. So now we can draw the vectors. Now if we join point R with point P, we get vector RP. Now we have to find angle POR in this triangle. So this angle theta. So we can use trigonometry to find this angle theta. So we can find the lengths of sides OR and OP in this triangle for finding the magnitudes of the given vectors. So let's start with vector OP. So we'll square the components, add them and square root the sum. So negative 7 square is 49 and 24 square is equal to 576. And 49 plus 576 is equal to 625, and the square root of 625 is 25. So that's the length of side OP in this triangle. Now we can find the length of side OR. So we get square root of 65, which is equal to 8.06. So this is the length of side OR. Now we can find the length of side RP, and for that we should first find the vector RP. So we should break up vector RP into its position vectors OP and OR. and we are given vectors OP and OR. Now we can subtract them. So we'll subtract their x and y components. So negative 7 minus negative 8 is equivalent to negative 7 plus 8, which is equal to 1. And 24 minus negative 1 is equivalent to 24 plus 1, which is equal to 25. Now we can find the magnitude of vector Rp. So I got square root of 626, which is equal to 25.02. So that's the length of side Rp. Now we can use cosine law equation to find angle theta. And since angle theta is opposite to the side with length 25.02, we'll start the cosine law equation with 25.02. Now we can evaluate the squares. So 25.02 square is equal to 626. 8.06 square is 65. Now 2 times 25 times 8.06, which is equal to 4.03. 403. Now we can add 625 and 65, which is equal to 690. So we have to subtract 690 from both sides. 626 minus 690 is equal to negative 64. And now we can divide both sides by negative 403. So I got cos theta equals 0.1588. And now we can do the inverse of cos. So I got almost 80.9 degrees. So this should be the final answer for part A. Now we can analyze part B. Determine the acute angle between the diagonals OQ and RP. So let's start by drawing the, the diagonals in the parallelogram. So we can start by sketching the parallelogram. R is point P, and now we can join the vectors OP and OR. Now since OPQR is a parallelogram, so in a parallelogram, opposite sides have equal length and are parallel to each other. So point Q will be somewhere here. We do not know the exact coordinates of this point, but we are just showing point Q so that we can draw the diagonals in this parallelogram. So the diagonals are OQ and RP. So we have to find this angle theta between the diagonals, the acute angle. Let's assume that these diagonals cross each other at point X. So we can analyze this triangle ORX. So I can draw it again. Now in this triangle, we know that side OR has length 8.06. Now in a parallelogram, the diagonals bisect each other. That means the point at which the diagonals cross each other is the midpoint of the diagonals. So that means side RX in this triangle is half the length of diagonal RP. And in part A, we found that vector RP has a magnitude of 25.02. So the length of side Rx will be half of 25.02, and 25.02 divided by 2 is equal to 12.51. So that's the length of side Rx. Now we have to find the length of side OX, and for that we need vector OQ. So let's start by finding vector OQ. Now vector OQ goes from point O to point Q. An alternate way to go from O to Q is to go from O to P and then from P to Q. And in a parallelogram, the opposite sides are equal in length and have the same slope. So therefore, vector PQ is equal to vector OR. And now we can add these two vectors. So we can add their x and y components. Negative 7 plus negative 8 is equal to negative 15. And 24 plus negative 1 is equal to 23. So this is vector OQ. And now we can find its magnitude. So negative 15 square is equal to 225, and 23 square is equal to 529. Now 225 plus 529 is equal to 754, and the square root of that is 27.46. So this is the length of diagonal OQ. That means the length of side OX will be half of 27.46. So 27.46 divided by 2 is equal to 13.73. So this is the length of side OX. Now we can use cosine law equation to find angle theta, and since angle theta is opposite to side with length 8.06, we'll start writing the cosine law equation with side 8.06. Now we can evaluate the squares. 8.06 square is equal to 65. 12.51 square, so 156.5, and then 13.73 square. Now we can multiply 2 times 0.51 times 13.73, which is equal to 156.5 plus 188.5129. Now we can subtract 345.0129 from both sides. So on the left side, we get negative 28. Oh, sorry, negative 280. Now we can divide both sides by negative 343.5246. So on the left side, now we do the division. So I got now we can do the inverse of cos. So I got 35.4 degrees. So this should be the acute angle between the diagonals. So this should be the final answer for part B. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.